Let's start by writing some text to a file. We'll be explicit about using the UTF-8 encoding because we have no way of knowing what your default encoding is. We'll use keyword arguments to make things clearer still. We'll assign to f the result of calling open. The first argument is the file name. The next argument is a string containing letters with different meanings. In this case, W means write and T means text. All mode strings should consist of a read, write, or append mode. One of the preceding should be combined with a selector for text or binary mode. So typical mode strings might be WB, write binary, or AT, append text. Although both parts of the mode code support defaults, we recommend being explicit for the sake of readability. The exact type of the object returned by open depends on how the file was opened, dynamic typing in action. But for our purposes, it's sufficient to know that the object returned is a file-like object, and as such, we can expect it to support certain attributes and methods. We've shown previously how we can request help for modules and methods and types, but in fact, we can request help on instances too. This makes sense when you remember that everything is an object. Let's call help on our file f. Browsing through the help, we can see that f supports a method write. Quit the help with Q and continue at the REPL. We'll write the string, "What are the roots that clutch?" to our file. The call returns the number of code points or characters written to the file. A few more lines, "What branches grow at 19 code points?" and "Out of this stony rubbish" with 27 code points. Note that it's the caller's responsibility to provide new line characters when they are needed. There's no WriteLine method on Python file objects. When we've finished writing, we should remember to close the file by calling the close method. Note that when we close the file, all the contents become visible to other programs. Closing files is important. If you now exit the REPL and look at your file system on Unix with ls-l, you should see the wasteland.txt file with 78 bytes. On Windows, you can do the same with dir. Here, you should see wasteland.txt with 79 bytes, one more than on Unix, because Python's universal newline behavior for files has translated the line ending to your platform's native endings. The number returned by the write method is the number of code points, or characters in the string passed to write, not the number of bytes written to the file after encoding and universal newline translation. In general, when working with text files, you cannot sum the quantities returned by write to determine the length of the file in bytes.